Good day everyone. Today, we'll be teaching you ways on how to verify identities using processes that we'll be showing you. First, let us introduce you to reciprocal identities. First, we have sine data is equal to 1 over cosecant data. Second, cosine data is equal to 1 over secant data. Third, tangent data is equal to 1 over cotangent data. Moving on, we now have ratio identities. First, we have tangent data is equal to sine data over cosine data. Next, cotangent data is equal to cosine data over sine data. Lastly, we'll be showing you the Pythagorean identities. In this identity, it is derived from the Pythagorean theorem, which is a squared plus b squared is equal to c squared. Then we'll substitute the values of x and y to a and b and r to c. This gives us x squared over r squared plus y squared over r squared equals r squared over r squared, which is the equation we'll be using to get the first Pythagorean identity, and in result, we will be having this equation. Lastly, this leads us to cosine squared theta plus sine squared theta is equal to 1. Moving on to the next Pythagorean identity, we have cosine squared theta plus sine squared theta is equal to 1. We will be dividing all terms by cosine squared theta. And this will give us 1 plus tangent squared theta is equal to secant squared theta. For the last Pythagorean identity, we have cosine squared theta plus sine squared theta is equal to 1. Then, we will divide all terms by sine squared theta, which results to cotangent squared theta plus 1 is equal to cosecant squared theta. For our first problem, we have secant to the fourth theta minus tangent to the fourth theta equals 1 plus sine squared theta over 1 minus sine squared theta. Then, divide your secant to the fourth theta minus tangent to the fourth theta by 1. This gives you secant to the fourth theta minus tangent to the fourth theta over secant squared theta minus tangent squared theta. Then, by using difference of two squares, this will lead you to secant squared theta minus tangent squared theta and secant squared theta plus tangent squared theta over secant squared theta minus tangent squared theta. And by means of cancellation, cancel like terms, which only gives you secant squared theta plus tangent squared theta. Moving on to the next step, change secant squared theta to 1 over cosine squared theta based on the reciprocal identities, and tangent squared theta to sine squared theta over cosine squared theta based on the ratio identities. Combine the two fractions into one equation since they have like denominators. Moving on to our next problem, we have cosine to the fourth theta plus cosine squared theta sine squared theta is equal to 1 minus sine squared theta. Using common monomial factoring, we will get the factor of the given terms that they all have in common, which is cosine squared theta. This gives you cosine squared theta multiplied by cosine squared theta plus sine squared theta. Then, since cosine squared theta plus sine squared theta is equal to 1 based on the Pythagorean identity, you now have cosine squared x times 1. Since cosine squared theta is equal to 1 minus sine squared theta, you can now prove your equation. For our next problem, we have tan x sine x equals secant x minus cosine x. Using the reciprocal identities, simplify secant x to 1 over cosine x and subtract it from cosine x, which is at its simplest form. Then multiply it by cosine x over cosine x to make your equation possible. Then you will be having 1 over cosine x minus cosine squared x over cosine x. Next step, combine the two fractions, which gives you 1 minus cosine squared x over cosine x. Next thing to do is to simplify, which makes it sine squared x over cosine x. Moving on, you will be distributing sine and making 1 as its denominator. And since sine x over cosine x is equal to tangent, you now have tangent x and sine x. For our next problem, we have 1 plus 1 over cotangent theta over 1 plus 1 over tangent squared theta equals tangent squared theta. First, change 1 over cotangent squared theta to tangent squared theta and 1 over tangent squared theta to cotangent squared theta based on the reciprocal identities. Then, change 1 plus tangent squared theta to secant squared theta and 1 plus cotangent squared theta to cosecant squared theta based on the Pythagorean identity. Then, based on the ratio identities, change both of this, which will give you this result. Afterwards, divide the two fractions, which gives you 1 over cosine squared theta multiplied by sine squared theta over 1. After multiplying, you were given the answer sine squared theta over cosine squared theta. And since sine squared theta over cosine squared theta is equal to tan squared theta, this proves your equation. For our last problem, we have cotangent x times secant x times sine x is equal to 1. Using the ratio identities, we will convert cotangent x to cosine x over sine x. Then, using the reciprocal identities, we'll convert secant x to 1 over cosine x. And since sine x is its simplified form, we will just retain it and use 1 as its denominator. Moving on, we will cross multiply, which gives us the reason to cancel both cosine x. This gives us 1 over sine x multiplied by sine x over 1. Again, cancel. This will only give you 1 over 1 and proves the equation. We hope that you learned something for today. Till we see you again next time. Thank you for watching!